This is a video from the Exam 1 review in my Calculus 2, and we're going to take a look at problem 17. It's the integral of x squared over 4 minus x squared to the 3 halves dx. The classic way to do this problem is by trigonometric substitution. So I'm going to draw a right triangle here and label this angle theta. And so I have a difference of squares within the parentheses there. And so what that tells me is that the hypotenuse is 2. And I'm going to make the side opposite to angle theta x. And then the square root of 4 minus x squared is the adjacent side to angle theta. So x over 2. Opposite over hypotenuse is sine theta. X is 2 sine of theta. Dx is 2 cosine theta d theta. So everything is straight substitution. So if I take square root of 4 minus x squared, this is equal to 2 cosine theta. Now, all I have to do is I'm going to raise both sides to the third power. Now, when I do that, on the left side, I get 4 minus x squared to the 3 halves. On the right side, I get 8, that's 2 cubed, cosine cubed theta. Now, this is the integral. It's all substitution all the time. Now remember, x is 2 sine theta. So I'm going to square x and get 4 sine squared theta divided by 8 cosine cubed theta. Okay, that's what 4 minus x squared to the 3 halves is. And then I'm going to take that and I'm going to replace dx with 2 cosine theta d theta. And then it's really, really, really slick from here. Now, 4 times 2 is 8, and there's an 8 in the denominator there. Remember, 8 over 8 is 1. And so this is the integral of sine squared theta divided by cosine squared theta d theta. So this is the integral of tangent squared theta d theta. But this is the integral of secant squared theta minus 1 d theta. And so this is tangent theta minus theta plus c. But let's go back to our triangle. Now, tangent theta is opposite over adjacent. So that's x over the square root of 4 minus x squared. Minus, now sine of theta is x over 2. So theta is inverse sine or arc sine of x over 2. So this is minus arc sine of x over 2 plus c. And that's how we do 17. Let's take a look at problem 18. Suppose we have the integral of x e to the 2x divided by 1 plus 2x to the second dx. This can be written as the integral of x e to the 2x times 1 over 1 plus 2x to the second dx. And this admittedly takes some experience of sorts. When I look at a problem like this, right, I try to go for a process of elimination, right? I'm not seeing an immediate u substitution, okay? So I eliminate u substitution. I'm eliminating partial fraction decomposition, right? Because of that e to the 2x in the numerator. So no partial fraction decomposition. It's not a product of sines and cosines, tangents and secants, cotangents and cosecants. The only thing really left that we can try is integration by parts. Now, I wrote it in a certain way on purpose because I know how to integrate 1 over 1 plus 2x to the second. I'm not so sure about x e to the 2x. And so when I do integration by parts, I'm going to let u equal x e to the 2x. dv is 1 over 1 plus 2x to the second dx. du is e to the 2x, right? So the derivative of x times e to the 2x plus x times 2e to the 2x dx. So that's just product rule. Now, what's the derivative of 1 plus 2x? That's 2. So I want to multiply the numerator by 2. But if I multiply the numerator by 2, I got to multiply the denominator by 2. Okay? So v is negative 1 over 2 times 1 plus 2x to the first. Okay? Now, make sure you're convinced of how I found v. All right? Now, this may not seem much, but look what happens. Notice the e to the 2x. I'm going to factor it out. And I'll be darned, I get e to the 2x times 1 plus 2x dx. And so this is uv, which is negative x e to the 2x divided by 2 times 1 plus 2x, right? Minus the integral of v du. So minus the integral of, now I'm going to get e to the 2x times 1 plus 2x times negative 1 over 2 times 1 plus 2x, okay, dx. So it's uv minus the integral of v du. Now, I'm going to cross off this 1 plus 2x factor in the numerator and in the denominator. Okay? From here, I'm going to get the following. I get negative x e to the 2x divided by 1 plus 2x, and let's remind ourselves, times 2. Okay? Minus a negative is plus. 1/2 the integral, right? I'm pulling out that 1/2, and then all I'm integrating is e to the 2x dx. And so when I'm done, I get negative x e to the 2x divided by 2 times 1 plus 2x plus 1/2 of, and it's 1/2 e to the 2x plus c. But half times a half is a fourth. So this is negative x e to the 2x divided by 2 times 1 plus 2x plus 1/4 e to the 2x plus c. And that's how we do problem number 18. Let's take a look at 19. Suppose I have the integral of cosine of square root of t dt. Now, I like to get rid of the radical whenever possible. And so what I'm going to do is I'm going to let w equal square root of t. So w squared equals t. 2w dw is dt. So we're going to rewrite this integral as follows. It's the integral of 2w cosine of w dw. This is a classic integration by parts problem. So I'm going to let u equal 2w. dv is cosine of w dw. V is sine of w, and du is 2 dw. And so this is 2w sine of w, right? That's uv minus the integral of v du, which is 2 sine of w dw. And so this is 2w sine of w minus 2 times. The integral of sine of w dw is negative cosine w plus c. But a negative times a negative is a positive, right? And so this is 2w sine of w, right? That's the first part. Plus a negative times a negative is a positive. So plus 2 cosine w plus c. But w is square root of t. And so this is 2 square root of t sine of square root of t plus 2 cosine of square root of t plus c. And that'll do it for this video for the Exam 1 review. And we did problems 17, 18, and 19, in fact. Thank you.